Reactivity series. The reactivity series is simply a list of metals arranged from most reactive to least reactive. The order is potassium, sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead, hydrogen, copper, silver, gold. The metals at the top react very easily. The metals at the bottom hardly react at all. Gold is one of the least reactive metals, which is why jewelry made from gold doesn't rust. Displacement reactions. A very important rule is a more reactive metal will displace a less reactive metal from its compound. Think of it like this. The stronger metal pushes the weaker one out. For example, zinc plus copper sulfate, zinc sulfate plus copper. Zinc is more reactive than copper, so zinc takes copper's place. If you swap them around, copper plus zinc sulfate, nothing happens because copper isn't reactive enough. Metals and acids. Metals above hydrogen react with acids. When they react, they produce a salt, hydrogen gas. For example, magnesium plus hydrochloric acid becomes magnesium chloride plus hydrogen. You would notice bubbles because hydrogen gas is produced. Easy memory tip. Remember, the more reactive metal goes in, the less reactive metal comes out. 2. Acids and alkalis. Now let's move on to acids and alkalis. An acid releases H+ ions in solution. An alkali is a soluble base that releases OH ions in solution. Examples. Common acids include hydrochloric acid, sulfuric acid, nitric acid. Common alkalis include sodium hydroxide, potassium hydroxide, ammonia solution. The pH scale. The pH scale runs from 0 to 14. pH tells us how acidic or alkaline something is. pH less than 7 equals acid. pH 7 equals neutral. pH greater than 7 equals alkali. Pure water has a pH of 7. The lower the pH, the stronger the acid. The higher the pH, the stronger the alkali. Indicators. Indicators tell us whether something is acidic or alkaline. Litmus paper. Blue litmus turns red in acid. Red litmus turns blue in alkali. Universal indicator. Universal indicator changes color depending on pH. Red equals strong acid. Orange and yellow, weak acid. Green and pink neutral. Blue, weak alkali. Purple plus strong alkali. Neutralization. When an acid reacts with an alkali, they neutralize each other. The products are always salt plus water. For example, hydrochloric acid plus sodium hydroxide produces sodium chloride plus water. This is called a neutralization reaction. Safety. Many acids and alkalis are corrosive. Always wear goggles during experiments. If chemicals touch your skin, wash with plenty of water. Memory tip. Acids produce H+ ions. Alkalis produce OH- ions. 3. Electrolysis. Electrolysis means using electricity to split an ionic compound into simpler substances. Electrolysis only works if the ionic compound is molten or dissolved in water. This allows the ions to move. Electrodes. There are 2 electrodes. Cathode. The cathode is negative. Positive ions, called cations, move here. At the cathode, they gain electrons. This is called reduction. Usually a metal or hydrogen is produced. Anode. The anode is positive. Negative ions, called anions, move here. At the anode, they lose electrons. This is called oxidation. Usually a nonmetal, like chlorine or oxygen, is produced. Common products. Molten sodium chloride, cathode. Sodium metal, anode. Chlorine gas. Brine, cathode. Hydrogen gas, anode. Chlorine gas. Copper sulfate solution, cathode. Copper, anode. Oxygen. Key rules. Positive ions always go to the negative cathode. Negative ions always go to the positive anode. Opposites attract. Easy memory trick. Cathode equals cations. Anode anions. Both words start with the same first letter. 4. Redox reactions. Finally, let's look at redox reactions. A redox reaction is a reaction where oxidation and reduction happen at the same time. These reactions involve the transfer of electrons. Oxidation. Oxidation means loss of electrons, often gain of oxygen, loss of hydrogen. Reduction. Reduction means gain of electrons, often loss of oxygen, gain of hydrogen. the best memory trick. Remember, oil rig. Oxidation is loss. Reduction is gain. This refers to electrons. Example, magnesium reacts with oxygen. Magnesium loses electrons, so magnesium is oxidized. Oxygen gains electrons, so oxygen is reduced. Both happen together. That makes it a redox reaction. Oxidation states. Another way to identify redox reactions is by looking at oxidation states. If the oxidation state increases, oxidation has happened. If the oxidation state decreases, reduction has happened. Everyday examples. Redox reactions happen all around us. Examples include rusting of iron, burning fuels, respiration in our bodies, batteries. Final summary. Let's quickly recap. Reactivity series. Metals are arranged from most reactive to least reactive. More reactive metals displace less reactive metals. Metals above hydrogen react with acids. Acids and alkalis. Acids produce H+ ions. Alkalis produce OH- ions. Acids have pH below 7. Alkalis have pH above 7. Neutralization makes salt and water. Electrolysis uses electricity to split ionic compounds. Cations go to the cathode. Muons go to the anode. Reduction happens at the cathode. Oxidation happens at the anode. Redox. Oxidation is loss of electrons. Reduction is gain of electrons. Oil rig helps you remember. Oxidation and reduction always happen together.